Assalamualaikum and hi everyone. Today we are going to learn chapter 3 predictable. This topic contains 3.1 classification of element and 3.2 periodicity. The learning outcome for this topic: at the end of the topic you should be able to describe period, group and block, SPDF, reduce the position of element in the periodic table from its electronic configuration. First, let's be introduced to the scientists that have invented the periodic table. There are many scientists involved, and the three famous scientists are Leterme, Dmitry Mendeleev, and Henry Moseley, and all the information about these scientists are given throughout the slide. The modern periodic table consists of 107 elements that are in 4 blocks: S, P, D, and F. There are 7 rows, is called period, and 18 vertical columns is called group. How the elements in the periodic table are arranged? The elements in periodic table are arranged in order of increasing proton number, and the position of element can be determined by using electronic configuration. A vertical column of element is called a group, and a horizontal row of element is known as a period. Elements in the same group have the same number of valence electrons, thus same chemical properties. For elements in group 1 and group 2, the group number is equal to the number of valence electrons. Elements in group 13 to 18, the group number are determined by the number of valence electrons plus 10. And for group 3 to 12, the group number is equal to the number of valence electrons of ns2 n-1 d1 to ns2 n-1 d10. These are the groups in the periodic table. We have group 1 and 2, group 13 to 18, and group 3 to 12. For element in group 1 is known as alkaline metal except for hydrogen. For group 2 it's alkaline earth metal. For element in group 3 to 12 is known as transition metal. For element in group 17 is known as halogen. And for element in group 18 is known as noble gas. Elements in the periodic table can be classified into 4 blocks according to the valence electronic configuration. These blocks are block S and P, main block, block D and F. We have block S, block D, block P, and the last one, block F. Your periodic table is divided into blocks according to the valence electronic configuration. Element in S block is for element in group 1 and group 2, and the valence electron configuration is ns1 to ns2. For element in P block, it is from group 13 to 80, and the valence electron configuration ns2 and p1 to ns2 and p6. For D block, the element in group 3 to 12 and the valence electron configuration are ns2 n-1 d1 to ns2 n-1 d10. For the S block, a few examples of elements in group 1 that are in S block: group number is equal to the number of valence electron. Example of element, we have lithium, sodium, and also potassium. The electronic configuration of lithium is 1s2 2s1. The valence electron configuration is 2s1 and the valence electron is 1. For sodium, the electronic configuration is 1s2 2s2 2p6 3s1. The valence electronic configuration is 3s1 and the valence electron is 1. And potassium, the electronic configuration is 1s2 2s2 2p6 3s2 3p6 and 4s1. And the valence electronic configuration is 4s1 and the valence electron is 1. Note, the valence electron are electron in the outer shell. Let's look at the other element in group 2 that is in S block. The group number is equal to the number of valence electron, and the example of element in group 2 are beryllium, magnesium, and also calcium. The electronic configuration of beryllium is 1s2 2s2 and the valence electronic configuration is 2s2, so the valence electron is 2. For magnesium, the electronic configuration is 1s2 2s2 2p6 3s2. The valence electronic configuration 3s2 and the valence electron is 2. For calcium, the electronic configuration is 1s2 2s2 2p6 3s2 3p6 and 4s2. The electronic configuration is 4s2 and the valence electron is 2. All the elements in group 2 have the same number of valence electron, it is 2. For element in P block, the group number is determined by the number of valence electron plus 10. Example for the element in group 13. We have element boron, element of aluminium, and also gallium. The electronic configuration for boron is 1s2 2s2 2p1 and the valence electronic configuration is 2s2 2p1, so the valence electron is 3. For aluminium, the electronic configuration is 1s2 2s2 2p6 3s2 3p1. The valence electronic configuration is 3s2 3p1 and the valence electron is 3. For gallium, the electronic configuration is 1s2 2s2 2p6 3s2 3p6 4s2 3d10 and 4p1. The valence electronic configuration is 4s2 and 4p1. The valence electron is 3. The valence electronic configuration is from the higher value of n, and it is from ns2 and np orbital. So for group 13, the valence electron is 3. For element in group 17, the group number is determined by the number of valence electron plus 10. Example for element in group 17 that is in P block are fluorine, chlorine, and bromine. The electronic configuration for fluorine is 1s2 2s2 2p5 and the valence electronic configuration are 2s2 2p5, so the valence electron is 7. For chlorine, we have 1s2 2s2 2p6 3s2 3p5 and the valence electronic configuration is 3s2 3p5 and the valence electron is 7. For bromine, we have the valence electronic configuration is 4s2 and 4p5, and the valence electron is 7. For element in D block, the group number is equal to the number of valence electrons of ns2 n-1 d1 to ns2 n-1 d10. Example 5, we have a few elements in D block. We have scandium, vanadium, and zinc. The electronic configuration of scandium, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p1. The valence electronic configuration start from ns2 to n-1 d1. So for scandium it will be 4s2, 3d1, and the valence electron is 3, so the scandium is in group 3. For vanadium, the valence electronic configuration is 4s2, 3p3, and the valence electron is 5, and it is from group 5. And for zinc, the valence electronic configuration is 4s2, 3d10, so it has 12 valence electrons, and it is from group 12. Let's look at the example 6 for element lithium. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p10, 4p6, 5s2, and 4d1. 5s2 and 4d1 is the valence electronic configuration for element of lithium. The valence electrons are 3. The valence electronic configuration are 5s2 and 4d1. So element lithium is from group 3. Let's do exercise 1 given. Classify the following element into its accurate group and block. You can try to answer the exercise. The answer for element P, valence electronic configuration is 3s2, 3p6, valence electron is 8, and the group from group 18. Element for block, it is from P block. For Q, the valence electronic configuration 4s2, 4p5, valence electrons 7 from group 17 and block P. Element R, valence electronic configuration 4s2, valence electron 2, group 2, block S. Element S, the valence electronic configuration 3d3, 4s2, valence electron 5, group 5, block D. T, valence electronic configuration 4s2, 4p6, the valence electron 8, group 18, and from block B. Element U, the valence electronic configuration 3d5, 4s2, valence electron 7, group 7, from block D. All of the elements in a period have the same number of highest principal quantum number n. The periods are numbered from 1 to 7. Example, element lithium, argon, potassium, and also scandium. For element lithium, the higher value of n is 2, so it is in period 2. For element of argon, the higher value of n is 3, so element argon from period 3. For potassium, the higher value of n is 4, so the element of potassium in period 4, and for scandium the higher value of N is 4, so the scandium is from the period 4. Element of the same period will have the same number of electron share. Exercise 2, you can try to answer all the questions in exercise 2. The answer for the exercise 2, element P, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and period 3. Q, the highest number of N is 4s2, 4p5, so it is from period 4. For element R, the highest value of N is 2, so it is from period 2. For element of S, the highest value of N is 4, so it is from period 4. Element T, the highest value of N is 2, so it is from period 2. For element U, the highest value of N is 4, so it is from period 4. And V, the highest value of N is 5, so it is from period 5. The position of metal, metalloids and non-metal in periodic table. Metals, element that shiny, solid at room temperature and good conductor of heat and electricity. All the element of metal is in yellow color. Metalloids is the element that have properties of both metal and non-metal, and all the elements of metalloid are purple color. For non-metal, it is the element that may be solid, liquid or gases, bad conductor of heat and electricity, and all the elements of non-metal are green color. You can try to answer exercise 3. The answer for exercise 3A, state the group and period for element M and N. So M it is from group 13 and period 3. For element N is from group 17 to and period 3. For element M, it has the highest number of N is 3, so it is from period 3, and the valence electron is 3. The valence electron configuration for element M is 3s2, 3p1, so the group for element M is determined by the number of valence electron plus 10, so we get group 13. For B, the molecular formula for the chloride compound for element M is MCl3, and for C, the molecular formula for the compound formed with element M and NBF are MN3. You can also try to answer exercise 4. And the answer for exercise 4, A, element Y, B, element R, C, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. For D, SPDF notation 1s2, 2s2, 2p6, 3s1, valence orbital 3s1. The quantum number N, L, and S is 300 plus half, or N, L, and S 300 minus half. The bottom number is equal to 6. The SPDF notation is 1s2, 2s2, 2p2, and the orbital diagram are given.